व्हाट्सअप कैसे हैं सब लोग अपोने कीमेन आचेन येल्लवनारू त्वाड़ा कियाली myself Chandrasekhar welcoming you all to this beautiful session for GATE 2024 aspirants. The series is 50 mark series where we ensure your 50 marks, at least 50 marks in your GATE 2024 examination. So we are going to cover those many topics which are frequently asked, which are more important from your GATE examination point of view, and which will get you at least 50 marks in your examination. So today's session is the part of very important, simple, basic and fundamental subject of mechanical engineering, that is thermodynamics, and the session is all about energy conservation law, that is the first law of thermodynamics. So please do let me know if I am audible and visible to everyone so that we can start this session. Can you guys hear me? All right. Shall we start the session? Please respond through the comment section if my audio and visual quality are fine. So the first law of thermodynamics is also known as Joule's law because it is developed through the Joule's experimental observation, and the law is also known as quantitative law. Why? Because according to the first law or energy conservation law, energy of the universe remains constant quantitatively. There are two ways in which energy is considered. One is quantity of energy, amount of energy. Another is quality of energy. The second law of thermodynamics talks about the quality of energy, whereas the first law of thermodynamics talks about the quantity of energy. That is why it is also known as quantitative law. So before I start my session, this is my quick introduction for those who are attending my session for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination, which is conducted by UPSC, and I have also worked in Steel Authority of India Limited for a couple of years. I am quite comfortable in fluid mechanics, thermal engineering, heat transfer and industrial engineering. So if you have anything to discuss in any of these subjects, any doubt in any of these subjects, or any doubt in general regarding your preparation, you can always connect with me through the mail ID which is mentioned at on the screen, that is chandra.shekhar7@byju's.com. And if you have not joined me on the Telegram group yet, it is my humble request, please join me on the Telegram. Once you join me on the Telegram, then you will be getting the notification of various examination. Are you guys aware that ISRO has given some update regarding the change of center? Are you guys aware about that? Today itself, ISRO had given the update. The dates are not yet announced, but yes, there is an update regarding the change of centers for the ISRO examination. All right. So please go through their official website regularly, and we will also share the important notification through the Telegram channel. PDF and study notes will also be provided to you. The update of the various sessions and daily important question and doubt clarification will also going to happen through the Telegram channel. The Telegram channel is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of this screen. Shall we start, guys? And there is another important announcement. I hope you guys are already aware and you have already registered for this live interactive free workshop, which is going to be conducted by Abhinav Negi sir. He is MTech from IIT Delhi, having more than 11 years of vast experience. He will going to discuss the strategy, the best strategy to follow for the next 6 months if you want to clear the GATE 2024 examination with the best possible score. The session will be at 7:30 p.m. today itself. So share this information to all your friends and colleagues who are going to appear for GATE 2024 examination and they have not yet started their preparation journey. To join this workshop, the link is already there in the description box. Go through the description box after the session to join, to register yourself. Registration is completely free of cost. All right, there are important links for the scholarship test also. There is a scholarship test on coming Sunday. So do register yourself for the scholarship test. Scholarship tests are important because they help you to evaluate your understanding about your preparation, as well as they will help you to get the scholarship based on your performance in the test. So you can purchase our paid courses with the discounted prices based on your performance in the scholarship. Shall we start, guys? Please do let me know. Those who are watching me live, please respond through the comment section if my audio and visual quality are fine. Yes, every one of you. Ready? Please keep your pen, notebook and calculator. Try to solve as many questions as possible. Try to get the answers correctly. Even if you are not getting the right answer, still you should give it a try and share your answer through the comment section, because the learning will definitely improve the mistakes will definitely improve your understanding. Shall we start? This is the first question on your screen. The session is about the first law of thermodynamics. What is the first law of thermodynamics? The energy entering into the system minus energy leaving from the system is equal to change in energy of the system. That is the simple expression for first law of thermodynamics or energy conservation law. Yes, what is the answer? I'm not able to see your comments. Yes. Please share your answer. The question says, along a path 1 to 3, there is a path 1 to 3. Let me call it as path A. A system absorbs 100 kilojoule as heat. The heat absorbed by the system is 100 kilojoule. Can we say Q is equal to plus 100? Heat added to the system is positive, and performs 60 kilojoule of work. It means the work is done by the system. Heat and work are the form of energy transfer and they depends on the path. That is why the sign convention will be required for defining the heat and work. Yes, very nice, Kiran. Well done. And so W, work done by the system, is 60 kilojoule. That is also positive. While along the another path 143, let me call it as path B, the system performs 20 kilojoule of work. Again, the work is done by the system. WB is equal to plus 20. This is QA, this is WA. Heat absorbed during the process 143, it means QB is equal to how much? If we draw the diagram, this is let us say 1, this is let us say 2, this is 3. There is a process 1 to 3. Let me call it as process A. There is another process 143, that is called as process B. So there are two processes, 1A and B. As you can see, initial and final states of both the process are same. Initial and final states are same. So when the processes are having same initial and final states, if it is a closed system, so the energy interaction will be in the form of heat and work. And if there is no change in potential energy, no change in kinetic energy, we can simply write it as delta U. So that will remain constant because an internal energy is a property that depends on initial and final states of the system. So can we say QA, QA minus WA is equal to QB minus WB, because change in internal energy will remain same because the initial and final states are same. So what is QA? That is plus 100 minus what is WA? That is also plus 60 is equal to what is QB? That is unknown minus what is WB? That is plus 20. Put the values of heat and work along with the sign. So QB is equal to 100 minus 60 plus 20 will be equal to 120 minus 60. That is 60 kilojoule. Good evening, Pagel world. Welcome. The correct answer to this question is option D. D will be the right answer for the given question. Is this clear to everyone? So I want everyone to keep responding. The more you respond, the more interesting and beautiful the session becomes. The more you communicate, the more improvement in your understanding you develop, the more confidence you build. So keep on sharing your knowledge, whether it is correct or incorrect, that does not matter. Let us move to the next one, question number 2. In an adiabatic process, what is the meaning of adiabatic process? Adiabatic process is when there is no heat transfer. Heat transfer is zero, or the system can be thermally insulated. Whenever the system is thermally insulated, the process undergone by the system will be definitely adiabatic process. 5000 joule of work is performed on a system in an adiabatic process. Let me call the process A as adiabatic. So 5000 joule of work is performed on a system. So work is done on the system. So it is minus 5000 joule, isn't it? It will be negative. Work is done on the system is negative. The system returns to its original state. There is a process A and the system returns to its original state by the process B. That was the initial state of the system, and this, or let me call it as 1 to 1, is a thermodynamic cycle. This is 1, this is 2, and it returns back to its original state while 1000 joule of heat is added. There is a process B, let me call it as non-adiabatic. So the 1000 joule of heat is added to the system. So Q, this is WA, QB is equal to plus of 1000 joule. The work done during the non-adiabatic process, QA is equal to 0. The work done in the non-adiabatic process will be how much? Now, if you write the energy conservation, Q minus W is equal to delta U, that is the first law of thermodynamics, because the initial state and final state are same. For a thermodynamic cycle, initial and final state are same. 1 to 1 is a thermodynamic cycle where the initial and final state become equal. So there is no change in internal energy for a thermodynamic cycle because internal energy is a property. So we can say Q is equal to W. If there are number of processes, then sigma Q is equal to sigma W. What is sigma Q? That is QA plus QB is equal to WA plus WB. If you put the values, what is QA? 0. What is QB? That is plus 1000 is equal to what is WA? That is minus of 5000 plus what is WB? Unknown. So WB will be equal to 6000 plus 6000 joule. Option C will be the right answer. Well done, Kiran, Pagel world. Great. Keep it up, guys. It is all about the sign convention and the first law of thermodynamics for a thermodynamic cycle. For a cycle, net heat transfer is equal to net work transfer, or we can say energy entering should be equal to energy leaving. That is the first law applied to a thermodynamic cycle. Let's move to the next question. Question number 3. Every one of you, please give it a try. Question 3 says, there is a balloon which is containing an ideal gas is initially kept in an evacuated and insulated room. Insulated means thermally insulated, Q is equal to 0. Evacuated means it is occupied by vacuum. There is nothing, there is perfect vacuum. The balloon ruptures and the gas fills up the entire room. What is this process called? whenever the balloon ruptures and the gas fills up the entire room, what this process called? Do you agree the process will be free expansion? Expansion against vacuum or unrestricted expansion? Free expansion is unrestricted expansion or expansion against vacuum. What is the correct answer for question number 3? Unrestricted expansion is expansion against vacuum. Which one of the following statement is true at the end of this above process? Yes, whenever there is vacuum, so can we say the vacuum does not offer any resistance to the flow at system boundary. The system boundary will not feel any resistance to the movement. So whenever there is no resistance at the system boundary, the work done by the system will be equal to 0. The work transfer will be equal to 0. Whenever there is a free expansion, the work transfer will be 0. And because of its insulated, Q is equal to 0 because it is given as it is insulated, thermally insulated system. So if we apply the first law, so can we say Q minus W is equal to delta U for a closed system? So if Q is equal to 0, if W is equal to 0, so delta U is equal to 0. So there is no change in internal energy. There is no change in internal energy. Internal energy decreases, that is incorrect. Internal energy of the gas increases, B is also incorrect. Both internal energy, D is also incorrect. D is also incorrect. So the correct answer to the question is option C. Both the internal energy and enthalpy. Why the enthalpy will remain constant? Because it is an ideal gas. For an ideal gas, U is a function of temperature only. Whenever it is an ideal gas, U is a function of temperature only. And if the U is constant, then temperature is constant, and H is also a function of temperature only. That is why both the internal energy U and H will remain constant for the ideal gas. Or we can say temperature remains constant. But let me tell you, the process will not be isothermal. Free expansion will not be an isothermal process. It is not isothermal. Free expansion is not isothermal. At the end of expansion, the temperature will be same as the beginning of expansion. Initial temperature and final temperature will be equal, but it is not isothermal. Isothermal means the temperature will be same at each and every point. Do you know that? So the curve will be, if we draw the temperature curve will be something like this. This is initial state, this is final state, and the temperature will remain constant. Temperature will remain constant, all right? But it is not an isothermal process. The correct answer is option C. Let us move to the next one, question number 4. Try to solve the next question, everyone. The question says a gas contained in a cylinder is compressed. Whenever there is a compression of a system or the gas, then the work is done on the system. The work required for compression being 5000 kilojoule. So work of compression is negative, that is minus 5000, because the work is done on the system. During the process, heat interaction of 2000 kilojoule causes the surrounding to be heated, which means the heat transfer is taking place from the system to the surrounding, because it is causing the surrounding to be heated. It means for the system, what is the heat transfer? Isn't it negative? Because heat is transferred from the system, minus 2000. Isn't it? Minus 2000 kilojoule causes the surrounding to be heated. The change in internal energy of the gas during the process is, if you understand the heat transfer for the system is negative, the work transfer for the system is also negative, then you will be able to get the right answer. Otherwise, you might end up getting incorrect answer. So Q minus W is equal to change in internal energy from the first law of thermodynamics. Apply the first law, you will get the answer. Q is equal to minus 2000 minus W is equal to minus 5000 is equal to change in internal energy. So change in internal energy is 5000 minus 2000, that is plus of 3000 kilojoule. There is an increase in internal energy because if the change is positive, final minus initial is positive, there is an increase in internal energy. The answer to this question is option C again. All right, those who are not able to do the calculation, or those who are not able to understand it in the first place, please try to observe and try to apply these concepts in your next questions. I hope this is clear. Now, other than this 50 mark series which is running for the GATE 2024 aspirants, we are having another series parallel to it for ISRO 2023 aspirants. As I have told you, there was an important update today from the official sources, or from the ISRO only, that you can have the change in center for your ISRO examination. It means there is some halchal regarding your ISRO examination. So you can expect the dates to be announced very soon. So we will try to be the first to give you that information. Keep on watching the official website and keep on watching do join our Telegram channels. We will share the information as soon as we will get from the reliable sources. All right, so there is a series which is already running, crash course, where we are discussing the formula revision, as well as we are discussing the revision. We are doing the revision of the formula, as well as the practicing some questions, important question. So in the previous session, Monday, I had a session on heat transfer. We had discussed conduction and heat exchanger, and tomorrow at 11 a.m. do not forget to join me on YouTube. Tomorrow at 11 a.m. we will have the formula revision session for convection and radiation mode of heat transfer. Not only formula revision, but we will have the practice of some important questions as well in the particular session. So do share this information to all your friends and colleagues so that more and more people can join, and we also feel motivated, and we will try to give you the best possible content through our sessions. All right, let us move to the next one. That this is theoretical question. The next question, question number 5. I am having around 10 to 12 questions in total. Question number 5 is on your screen. Do get me the answer. The heat absorbed or rejected during a polytropic process. What is a polytropic process? Whenever there is a heat transfer as well as work transfer. The process in which there is heat and work, both transfer take place. Yes, Arnav, Pejal, Kiran, well done. So polytropic process is denoted by, for an ideal gas, polytropic process is denoted by PV to the power n is constant, where n is called as polytropic index. N is called as polytropic index, which lies between gamma and 1. Gamma is the adiabatic index, which lies. So from here we can write P2 by T1 for an ideal gas is equal to P2 by P1 to the power n minus 1 by n is equal to V1 by V2 to the power n minus 1. This is the relationship we can use for the ideal gas system undergoing a polytropic process. As the temperature increases, pressure will also increase, but volume will decrease. As the temperature decreases, pressure will decrease, but the volume will increase. That is about the polytropic process. And if we calculate work, that is integration of PdV using this expression from 1 to 2, then you will get gamma minus n upon gamma minus 1 multiplied by P1 V1 minus P2 V2, sorry, just hold on. For work transfer, what we will get? For work transfer in a polytropic process, P1 V1 minus P2 V2 upon n minus 1, and the heat transfer is given by gamma minus n upon gamma minus 1 into P1 V1 minus P2 V2 upon n minus 1. N minus 1. That is the work transfer in the polytropic process. So option C is the correct answer. Can we write this Q to be M into specific heat for a polytropic process into delta T, where specific heat for a polytropic process is N minus gamma upon N minus 1 into specific heat at constant volume. So this is less than 0. This is negative. Why it is negative? Because N is less than gamma. Because N is less than gamma, that is why this is negative. So we can say when there is a heat added for heat addition, Q is positive. If Q is positive, then C is always negative. For making the value of Q to be positive, we can say delta T should be negative or the temperature will decrease. For heat rejection, in case of heat rejection, Q will be negative. If Q is negative, then C poly is already negative. Specific heat for a polytropic process is already negative. So delta T will be positive. It means temperature will increase. For the polytropic process, you should be aware of these information. All right. Let us move to the next question. But before that, today there will be a workshop. You can go through the description box after the class to register yourself for the workshop, and there will be a scholarship test on the upcoming Sunday. You can register yourself for the same, and you can also see the link for downloading the free ebooks for your efficient preparation. So guys, please do not forget to like and share this session so that it reaches to all the students who are sincerely preparing for GATE 2024. It will help you to improve their understanding for the first law of thermodynamics. Let us move to the next one, question number 6. The next question on your screen. Please give it a try. The contents of a well-insulated tank are heated by a resistor. The tank is well insulated. What does that mean? It is thermally insulated. Insulated means thermally insulated. So we can say there is no exchange of heat taking place. Q is equal to 0. There is no possibility of heat transfer, isn't it? And the content are heated not by the heat transfer. The content are heated by the current flow, or we can call it as work transfer. Do you understand it or not? There is a current flowing across 23 ohm resistor. Current flowing is 10 ampere, and consider the tank along with its content as a thermodynamic system. The rates of heat transfer, work transfer. So it is electrical energy getting transferred into the system, and that causes the heating of the system, that is known as Joule's heating. So it is the work transfer. Work is done on the system. So work transfer is negative I square into R in watt W dot per unit time, that is joule per second or watt. So work transfer will be negative. What is the answer for the work transfer? That is W dot will be equal to minus 10 square into R is 23 ohm. So it is 20 in kilowatt. Is it watt or kilowatt? Is it 23? What is the answer? It should be kilowatt actually. It is kilowatt. Is it kilowatt? Yes, it is already written kilowatt. It is already there in kilowatt. So W dot is equal to, in watt it will be minus 2300, or in kilowatt it will be minus 2.3 kilowatt. That is the work transfer. Work is done on the system, that is why it is negative. And there is no heat transfer. If we apply the first law of thermodynamics, Q minus W is equal to delta U. So Q is 0, W is minus of 2.3, that is delta U. There is a negative sign for subtraction and there is a negative sign for work transfer to the system. So delta U is equal to plus 2.3 kilowatt. There is an increase in internal energy, or we can say there is an increase in temperature. That is how the heating will take place. So what is the correct answer? Option A will be the right answer. Yes, Pejal world. Arnab, well done. Kiran, where are you? A will be the correct answer for this. So many students commit mistake because they start thinking there is a heat transfer. It is called as, the energy transfer will be called as heat transfer only when it is due to the temperature difference. All the other forms of energy transfer are treated as work transfer. Electrical energy transfer is called as electrical work transfer. Mechanical energy transfer is called as mechanical work transfer. Pedal wheel work is the work transfer to the system. So it will be negative. The next question. The next one, the first law of thermodynamics takes the form W is equal to minus of delta H. The first law of thermodynamics takes the form W is equal to minus delta H when applied to. What is the answer to this one? This is our question number 7. You must be knowing first law of thermodynamics for a closed system. What is the first law of thermodynamics? Energy in minus energy out is equal to change in energy of the system. That is the general expression for first law of thermodynamics. This is valid for any system, any process. Any system plus any process. Now for a closed system, what is the meaning of closed system? In case of closed system, there is no mass transfer. Energy transfer takes place. Energy transfer takes place in three ways. One is in the form of heat transfer, another is in the form of work transfer, or the third one is along with the mass transfer. So if it is a closed system, then the energy transfer will take place only in the form of heat and work. So Q is the heat added to the closed system and work is the done by the closed system. So this is energy out, this is energy in. So Q minus W is equal to delta E for the system. That is for the closed system. Isn't it? Do you understand? Yes. Now, what is delta E for a closed system? Delta E is equal to delta U plus delta potential energy plus delta kinetic energy. Change in internal energy plus change in potential energy plus change in kinetic energy is delta E. This is for a closed system. And if it is an open system, if we talk about an open system, or specifically steady flow process, for a steady flow process, U will be replaced by H, enthalpy. There is a proper derivation because there is a PV energy, flow energy is also coming into picture. The energy flowing due to mass, that is called as flow energy. So U will be replaced by H, enthalpy. So Q minus W is equal to delta H plus delta PE plus delta KE. That is the energy conservation equation for an open system. That is the first law of thermodynamics for an open system or having the steady flow process. Now if we want W is equal to delta H, then how we will get W is equal to minus delta H? So we can say if Q is equal to 0 and delta potential energy, delta kinetic energy is equal to 0, if these are the situations, then W is equal to minus delta H. That will give you the answer. So it cannot be a closed system, it cannot be a closed system. A, C and D are incorrect. It is an open system undergoing an adiabatic process. It must be an open system undergoing an adiabatic process with negligible change in kinetic and potential energies. With negligible change in kinetic energy as well as potential energy. Alright. So that is the first law applied to the steady flow process. And if you put the value of change in internal energy, change in enthalpy, change in potential energy and change in kinetic energy, then we obtain the steady flow energy equation. If we write it per unit mass. So from here what we observe is Q minus W is equal to delta H plus delta PE plus delta kinetic energy. If we write per unit mass, then we will get H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. That is called as steady flow energy equation. First law of thermodynamics applied to the steady flow process. First law of thermodynamics which is applied to the steady flow process. Alright. That is called as steady flow energy equation. The unit of each and every term is joule per kg. You should put all the parameters in their SI unit. C1 and C2 are, what are C1 and C2? C1 and C2 are the velocities at inlet and outlet respectively. Now there is a steam turbine. It is a steady flow device. So we can apply the steady flow energy equation. A steam turbine receives steam steadily at 10 bar with an enthalpy of 3000 kilojoule per kg. H1 is equal to 3000 kilojoule per kg and discharges at 1 bar with an enthalpy of 2700 kilojoule per kg. The work output is work is done. So it will be positive 250 kilojoule per kg. It is specific work. 250 kilojoule per kg. What is the answer? What will be the answer? Very nice. And the changes in kinetic energy and potential energy are negligible. So C1 by 2, C2 by 2, GZ1, GZ2, these are getting cancelled out. And the heat transfer from the turbine casing to the surrounding will be how much? The question is to find out the value of Q. So H1 is 3000 plus Q is unknown, H2 is 2700 plus W is given as 250. So we can easily find out what is the value of 3000 minus 2950, that is plus 50 kilojoule per kg. It is kilojoule per kg actually. B is the correct answer. If the mass would have been given, then you could have multiplied with mass also. If the mass flow rate would have been given, then you could have multiplied with the mass flow rate to find out. But because there is no mention about the mass flow rate or the mass, that is why we will assume the mass to be 1 kg. The next one, the next question, question number 9. Solve this one. A piston cylinder device contains 5 kg of air, that is the mass of air given, and air is an ideal gas at 400 kilopascal and 30 degrees Celsius. During a quasi-equilibrium isothermal expansion, quasi-equilibrium means reversible. During a reversible isothermal expansion process, 15 kilojoule of boundary work is done by the system. So there is a work done by the system is 15 kilojoule, right? And 3 kilojoule of paddle wheel work is done on the system. I told you paddle wheel work will be done on the system. So W2 is equal to minus 3 kilojoule. The heat transfer during this process is, we need to find out the heat transfer. Because it is isothermal process, so temperature is constant and U is a function of temperature only for an ideal gas. For an ideal gas, internal energy is a function of temperature only. So delta U will be 0, isn't it? For an ideal gas, delta U will be 0. And what is W net? W net is algebraic sum of total work transfer. So 15 plus minus 3. That is net work transfer or net work done is 12 kilojoule. Work done will be 12 kilojoule, and we can write the first law of thermodynamics to get Q minus W is equal to delta U. Delta U will be 0. So Q is equal to W net. That is plus 12 kilojoule will be the answer. It will be 12 kilojoule, which is the correct answer. Option A is the right answer for this question number 9. So please do share this session, guys. Those who have joined me late, do not forget to share and like. And don't forget to join me tomorrow at 11 a.m. to have the complete revision of convection. Very, very important. There are a lot of formula in convection. And because the convection is related with the fluid mechanics, so there is more chances of getting the questions from the convection in the heat transfer subject. And radiation also, we will discuss the radiation and convection mode of heat transfer in tomorrow's 11 a.m. session on the YouTube. Let us move to the next question. Question number 10 on your screen. Question number 10. A small steam vessel. Again, it is a steady flow device. And because it is a steady flow device, so we can apply the steady flow energy equation. What is the steady flow energy equation? That is the first law applied to the steady flow process. If we write per unit mass, then per unit mass H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W per unit mass. It is perfectly insulated, so Q is equal to 0. That is given. And doing no shaft work, W is equal to 0. Causes a drop of this much enthalpy. H1 minus H2 is given as 0.8 kilojoule per kg. The kinetic energy of steam at inlet is negligible. C1 is 0. The velocity of the steam at exit is C2 we need to find out, but you will get the value of C2 in SI unit only when you will put all the other parameters in SI unit. So C1 is 0, Q is 0, W is 0, GZ1 is 0, GZ2 is 0, and we can find out C2. We can find C2 from here. What is the value of C2? C2 will be equal to twice of H1 minus H2 and then under root. So under root twice of what is H1 minus H2? It is 0.8 kilojoule per kg. So in terms of joule per kg, it will be 800. So it will be under root of 1600, that is 40 meter per second. So many students commit mistake in taking the units correctly. So the answer is 40 meter per second for this question number 10. Right? B is the right answer. Yes, Rishabh. Well done. Good, good. The next question is common data question. From the steady flow process, let us solve the next one. Common data. The common data is air enters an adiabatic nozzle. Adiabatic nozzle means Q is equal to 0. And air can be treated as an ideal gas. Enters at 300 kilopascal, that is P1, 500 Kelvin T1 with a velocity of 10 meter per second, that is C1. It leaves the nozzle at 100 kilopascal P2, velocity of 180 meter per second. The inlet area, that is A1, is 80 centimeter square. The specific heat of air is given as 1008. You are supposed to take this value only. Do not take 1005 joule per kg Kelvin. The exit temperature of the air is, if it is passing through the nozzle, this is inlet, this is outlet. We need to find out the exit temperature of the air. Can we apply the steady flow energy equation? Nozzle is not used for any work transfer. Q is equal to 0 is equal to W. There is no work transfer for a nozzle. So we can say H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. Can we use, do let me know, can we use T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma? Can we use this expression or not? To get the value of T2, do we use the steady flow energy equation or can we use this expression? Yes or no? Can we use this expression to find the value of T2? Waiting for your response. Because T1 is given, P1 is given, P2 is given, gamma for air is 1.4. Why we cannot use Rishabh? If we cannot use, why not? This is used for ideal gas system and air is an ideal gas. Why we cannot use? The system is an ideal gas. This expression is used for the ideal gas system undergoing reversible adiabatic process. It is used only for reversible adiabatic process, and if there is nothing mentioned regarding the reversible adiabatic process, then we cannot use this. That is why we are supposed to use the steady flow energy equation. So there is no change in potential energy, heat transfer is 0, work transfer is 0. So H2 minus H1 is equal to 1 by 2 C1 square minus C2 square, isn't it? Or we can write Cp into T2 minus T1 is equal to 1 by 2. We can write it as C1 plus C2 into C1 minus C2. Isn't it? The only unknown is T2. Can you find out the answer? So Cp 1008 into T2 minus T1 is 500 Kelvin is equal to 1 by 2. What is C1 plus C2? 10 plus 180? 190 into what is C1 minus C2? That is 10 minus 180 minus 170. Can you find out the value of T2 from here? Can you guys find out the value? Yes, Arnab. Whenever the process is adiabatic, adiabatic means thermally insulated system. Adiabatic means the heat transfer is 0, whether it is reversible adiabatic or irreversible adiabatic, it does not matter. Whenever the process is adiabatic, there is no heat transfer. So what will be the answer? 190 into 170 divided by 2. This is negative sign. Divide by 1008, right? So minus 500. So answer will be 483.98. 483.98. Are you getting option C? It will be T2 will be equal to 483.98 Kelvin. Do not forget this negative sign. Do not miss this negative sign. 483.98 Kelvin. So the correct answer is option C. This was the first part, and there is another part for the same question. There is another part for the same question. The second part says, this is the same data. Data is still the same. The exit area of the nozzle in centimeter square is. We need to find out the exit area of the nozzle. So according to the mass conservation, we can say m dot I minus m dot E is equal to dm by dt in control volume. That is the mass conservation. That is the mass conservation equation, isn't it? So this will be 0 for steady flow. For the steady flow process, the change in mass in the control volume is 0. So we can say m dot 1 mass entering will be equal to mass leaving. That remains constant. 1 is inlet, 2 is outlet. Let me call 1 for inlet and 2 for outlet. So that is the rho 1 A1 C1 is equal to rho 1 A1 C1 is equal to rho 2 A2 C2. And how to calculate rho 1? Because it is an ideal gas, so rho can be written as P1 upon RT1 into A1 C1 is equal to P2 upon RT2 into A2 into C2, isn't it? RR will be getting cancelled out. The question is to find out A2. So A2 is equal to P1 by T1 into T2 by P2 into P1 by T1 into T2 by P2 into C1 by C2. Put the value. What is P1? P1 is 300 kilopascal. Divide by P2 or T1 500 Kelvin into T2. T2 we have already calculated 484 upon T1 500. Sorry, upon P1. Put the values. P1, sorry, T2 by P2. What is P2? P2 is 100 kilopascal into C1. Velocity is 10. C2 is 180. That will give you the answer into A1 also. Into A1 also. Into what is A1? A1 is 80. That will give you the answer in centimeter square. Can you do the calculation? 300 into 484 multiplied by 800 divided by 500 into 100 into 180. Isn't it 12.9? Isn't it 12.9? Arnav, Risa, why are you getting option C? Isn't it 12.9? Are you getting options D or not? The correct answer to this question is option D, 12.9 centimeter square. 12.9 centimeter square. Is this all clear? So because I have not covered the first law for unsteady flow process, let me write for unsteady flow process. So if we talk about the mass conservation, for the mass conservation, अच्छा डेंसिटी कंसिडर नहीं की, अच्छा A1 C1 इज इक्वल टू A2 C2 कर दिया, नहीं ना 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 ना, इट इज कंप्रेसिबल फ्लूइड. Because the fluid is compressible, that is why you need to take care of variation in the density. Density varies with temperature and pressure. Alright, so the D, option D will be the correct answer. So we can say mass entering minus mass leaving is equal to change in mass in the control volume. That is 1 for initial state, 2 for the final state of the control volume, and I for inlet and E for outlet or exit. So when the mass entering is 0, when there is no mass entering into the control volume, then Mi will be 0. When there is no mass leaving from the control volume, Me will be 0. If the control volume or the system is initially evacuated, then M1 is 0. And if the system is finally evacuated, then M2 is 0. And if we talk about the energy equation or first law, then we can say energy entering is Q plus Mi Hi. That is the energy entering. The energy will be entering in two ways. One is heat transfer, another is along with the mass transfer. And the energy leaving is in terms of work transfer and along with the mass transfer, Me. So Q plus Mi Hi minus W plus Me He is equal to, that is E in, this is E out. This is energy leaving, this is energy entering, is equal to change in energy, or we can say M2U2 minus M1U1 of the control volume, because change in energy is internal energy M1U1. So this is our energy conservation equation. This is our energy conservation equation. For the unsteady flow process. I hope this is clear. I for inlet, E for exit, Q for heat transfer, W for work transfer, and U is the internal energy, H is the enthalpy. H is the enthalpy and U is the, or it is specific enthalpy and specific internal energy. So that completes our and that is specific internal energy. The unit is joule per kg. So this will be mass conservation equation and energy conservation equation for the unsteady flow process. I hope this is clear, and I hope you guys enjoyed the first law of thermodynamics. If anybody is having any doubt, anything to ask in the first law of thermodynamics, you are most welcome. Otherwise, let me stop here only. Tomorrow at 5 p.m. I will be meeting with you guys again, and we will discuss the second law of thermodynamics through the questions practice. All right. So please do revise the second law of thermodynamics a little bit so that you will be in a position to ask your doubts, to get your doubts clarified, and you can be able to involve yourself as much as possible. So this is my mail ID. You can always connect with me through the mail ID, and this is my Telegram link to join. If you have not joined me yet, I will share the PDF of this session to my Telegram group so that you can revise these questions or you can practice these questions again at home. All right. And before I end my session, there are two beautiful series which are running on our BYJU'S YouTube platform. That is Sunday Ka Funda series. Every Sunday we bring some interesting concept through the practical application, live experiments, or the practical examples to make your understanding more interesting and beautiful. Other than that, there is a Super Saturday series which is running on every Saturday. We bring you the stories of the legends who had done a lot of research work in engineering. All right. So do not forget to subscribe our BYJU'S YouTube channel. And that is all from my side, guys. Thank you very much for joining in. Take care. Stay safe. स्टे मोटिवेटेड एंड कीप डूइंग द हार्ड वर्क। तो जाते जाते मैं यही कहना चाहूंगा कि सोचने से कहां मिलते हैं तमन्नाओं के शहर, सिर्फ सोचने से कहां मिलते हैं तमन्नाओं के शहर, चलना भी जरूरी है मंजिल पाने के लिए। विद दिस